Howdy folks, Mr. Holdeman here. Now, as a teacher, we get a lot of questions like, when am I ever going to use this? And short answer is, you're never going to use something that you don't know how to look for. So today we're going to learn something new, and we're going to try to find that in examples of our everyday life. So, Life of a Science Teacher will walk you through a few examples. And before we do that, we've got a little bit to learn. So you should check out the Google Doc that is attached to this assignment. You're going to have to submit that by the end of the assignment. So last thing you do before you leave this is submit that assignment. But we're going to follow along with it. So the first thing on there, you can see at the top, goes back to the energy unit. And what we saw there was that where we have a difference in temperature, high temperature and low temperature, energy always flows from high to low, from hot to cold. And you'll see that pretty consistently in a lot of sciences. So energy flows from high energy to low energy. So if we pick up a pen, this has high potential energy, and when we drop it, it goes to low potential energy. See, it works. There's science for you right there, every day. So on the other side of that document, you can see that there's a pressure. So with gases, the same principle is true, that gases, whenever there's a difference in pressure, gases move from high pressure to low pressure, or cause a force that pushes from high pressure to low pressure. So on the screen here, I'll include both of those arrows, so high temperature to low temperature, as we know from the energy unit, and then from high pressure pushing toward low pressure. So that's one thing I want you to keep in mind as we go through a few of these examples. Now, what are we going to do? So we have 4 examples, and on your document, you have a description, you have a prediction, an observation, and an explanation. So I want you to, when I explain it, I want you to write the description of the event, so you type that out, and then a prediction of what's going to happen, and then we'll go through the example and you'll write your observation. Once you do that, I need you to think through an explanation as to why that happens, so using your gas laws, and then you'll take a quiz on those examples, on those demonstrations. That quiz is going to ask you what law you think relates those variables or explains the situation, and then what specific answer explains the situation as well. So let's get started. First demo. Oh, well, hold on. Just need to breathe for a second. Inhale. You can breathe with me. And exhale. Because as a science teacher, that's something I do on a daily basis, is breathe. Especially when people ask me questions like that. Oh, and you know what? That's demo number 1, breathing. So, what I want you to do, type in description, what's going on. You can practice, go along with me if you need to, and write a prediction of what you think is going to happen in terms of the gases, and then observe what happens. Maybe you can watch it again, try it for yourself, try breathing. Here we go. Ready? As I breathe in, and as I breathe out, what's going on with the gases? So, type of prediction. I'll just wait here. Or you can pause the video. Pause. We'll meet back in just a second. Cool. Let's do demo number 2. Demo number 2. As a science teacher, or just as a human, I think about chemistry when I'm eating breakfast. So, this morning, I was eating my classic bowl of mini wheats with an egg separately. And I got out the mini wheats, poured a bowl. I got my milk out, 1%, because, you need vitamin absorption with some of the fat in there. Can't go skim because it tastes like not so good. So, eating my cereal, just thinking about chemistry to myself, and all of a sudden I hear a boom. That was it. It was all it took, just a little boom. I looked around for it and noticed it was coming from the milk container. So I left the milk container out. It was in the fridge. I left it out with the cap screwed on, and it just made this little pop noise. So predict what happened to the gas in that milk to make that noise. Go ahead, type it in. Pause if you need to. And then I'll show you a little video here. Most exciting chemistry action that you've ever seen. No explosion, but it's a little bit better. Check this out. Okay, so you can't really see it here, but if you look closely at the label, you'll see it puff out just a little bit. I'll explain more in a minute. See, there we go. See the milk carton just increases in volume. Yeah, isn't that great? Why does it do that? Come up with some explanation. I left the milk out on the counter, and it increased in volume and expanded. Why did it do that? What law? And can you explain that law? We're not even through breakfast, and we've got 2 demonstrations of gas laws for chemistry. Let's move on to number 3. So number 3, Mr. Lackey. Let's bring him into this. So Mr. Lackey, if you don't know, Mr. Lackey makes his own sourdough, which is a pretty involved process. And part of that involves a starter, which is a little bit of yeast, and you put in a little bit of wheat, and you pack them into not quite like, it's similar to this. So imagine that there's a little bit of yeast, and you mix in a little bit of flour, maybe some water in there. It tells you to put the cap on, but don't screw it down. You don't want to screw it tight. You just want to leave it sitting on top of your container. And then you leave it out. So the idea is that the yeast eats the sugar and it causes a chemical reaction. So what would you notice? What do you predict is going to happen when you see yeast creating a chemical reaction with that sugar? What's going to happen? Think of the gases. So as we leave that gas sit there, and I'll show a video in just a second. So type your ideas. Now, let's observe. Wow, look at that yeast. What's going on? So some observation, we see more bubbles. What explanation can you come up with? So we've got Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, the combined gas law, ideal gas law. Which one best explains this and why? All right, so we're getting toward the end of the day. We have consumed our consumables, we've eaten our bread, maybe you had a can of Coke with dinner. Now, you could go to the can crusher in the garage and crush the can so it takes up less space in the recycling, or you could do it this way. You could, with a little bit of water in the bottom, heat up the can on the stove, and then very quickly flip it over into some ice cold water. What's it going to do? What's it going to do? Let's observe.
Ready?
Oh my God! Did you see that? We don't need a can crusher. All we need is some cold water, an empty can, some regular temperature water, heating source. I mean, we can do it so much easier and use chemistry at the same time. Wow. So, explanation. Which law is it and what happened?